Hello and welcome to another episode of Free Code Friday. My name is Jason Bach and I had something in my throat. Probably some of this tasty, calorie-rich muffin. In the last episode I finally got this pseudo program, the 99 bottles of beer on the wall, to actually do the right thing, which was highly encouraging. So I went off to lunch and didn't have a lot, had like 2 tacos and a bottle of water, and I came home, I'm like, I'm going to be doing a chest and back exercise later on this afternoon. I need the calories, and I'm going to celebrate a little bit. So, sorry if I grab some muffin and milk during this recording, but too good and I couldn't pass it up. Okay, so where are we? We need to do again. Need to do again. There we go. So what does again look like? Again, I'm going to make sure I do this right. So if the argument is true, it's like the opposite of defer. So if I say again, if again, then you do this, but you don't decrement the count. Okay. So if again, then you do your code. And then I also need to keep track of that you said, yes, you had a successful again. So this will return a true, and then the code's responsible for saying if it's a positive thing, you execute it either way. Okay. But you don't, okay, that's actually true. So you basically call again, and you don't have to do an if check, you just do the next thing. But the engine's going to be responsible for keeping your line numbers there. Now this is another thing down here is the statement of compound structure may be a compound statement. If any direct program is true and serves any is false, true, the statement remains on the to this. In practice, a single again and single defer clause cover all possibilities and the order is unimportant. So long chains of multiple agains deferred are unnecessary. True, but not disallowed. Because if I do an again and then I do a defer, if any again arguments, the statement remains on the to-do list, whether it's actually executed or not. So I guess what this is saying is, I say again 1, which means do it, but then I defer this from happening. But again happened first. So does that mean that, well, it would only happen if you have an instance of line 1, which you would, right? Oh, except there's got to be a way to, 4. See, now this is also weird. I don't know what this actually, because you have 1, 2, 3, 4, 5, 6, 7, 8, 9. This means do 1. This means do 4. This means -3. Well, what would a -3 do? You don't have a -3 line. It doesn't make sense. And then they talk about -1 and -2. minus 7 minus 3. Let me make sure I understand that right. An expression is valued as positive integer and an instruction to submit the line with that number to the to-do list. A single line may appear in the to-do list multiple times because of this, and each instance must be executed separately. I know you could read this, I'm just reading it out loud. An expression which evaluates a negative integer is an expression to remove the line with the absolute value of the number from the to-do list. If the line in question is not on the to-do list, nothing happens. Oh. See, this harkens back to when I was in grad school. One of the biggest lessons I learned when I was writing my thesis is give examples, but then explain what this does. Sure, you gave an example here, but you would say, for example, in this case, when line 1 is executed, you'd add another instance of line 4, you'd have 3 instances of line 6, and you would remove one instance of, add 3 instances of line 5, and remove 1 instance of line 6. That makes sense, because then you come down here and you can say, oh, remove 1 of line 3. Remove the number of 2 for line 2. That makes a lot more sense. Okay, so that's clear in my head. Okay. The thing though is that, again, if you pass in, again, for the number of lines for 1, no, you're just saying, does it exist? And then you say defer. So again, does nothing for the execution. It always happens. You're just keeping track if you should remove it or not. So if you call again and it gives you a false, then you know you need to remove it. Okay. Defer does it override it? See, I'm going to code this one way, and then it's not going to be the right way. I know that right now. I know that right now. We are recording. Good, good, good. It's just which one comes in first. Does it matter? Last one wins? Because what happens if I did again of true, which would execute it and leave it on the list? If any again argument is true, the statement remains on the to list, whether it is actually executed or not. So if again is called, you have to leave the argument on the list. Defer will tell you whether you can remove it or not. So I'm reading this as saying again is going to override defer in terms of so if you said at any point, yeah, and this is also an interesting point. I'm going to write this down. Again and defer must or the current value. What I mean by that is if you call again once and you get a true, and then somewhere down in your statement you call again with a false, doesn't matter. This is saying any argument, any again argument is true. It stays on the to-do list. Okay, so even if you passed in a true or a false, doesn't matter. Okay. that only determines whether you execute the rest of what you can think of it as a block. Like again, there's a block there, and then defer, there's a block there. You can think of it that way, I guess, is a good way of looking at it. So if you get it any agains, you would automatically keep the line on the list. If you didn't, then what you need to do is look at any did you get defers. Because the way I have this right now is, I actually have my code up here. Should statement be deferred? So the first thing you would do is say if should state was should statement be deferred? Should statement be again? I can't think of a good phrase that doesn't sound ridiculously stupid. Was again called with true. Well, before I forget, there. Just basically saying, did you ever call it with a true? And we'll capture that. And that doesn't break anything. And doesn't break that either. Okay, good. So the thing I would need to have here is, I don't have an again here, so we need a bool again, bool should keep. I think it's really what you're saying is, yeah, should you keep the line? Should statement be kept? And so then public bool again, bool should keep. This is also going to be similar to this. So I gotta be careful here. Oh no, let's just write it. This dot should statement be kept, or should keep, return should keep. Okay. And then here I got to say, should statement be deferred? Should statement be kept is false. And then do the same thing here. This dot should be kept, false. Now, if this should statement be kept, you only check that if it wasn't supposed to be kept. Again, I got to go through the Boolean logic in my head. If the statement should be kept, then you would never need to look at the line count updating. So if you didn't do that, then the thing you have to look at is say, was defer called? Because, yeah, I think that makes sense. If you, and I can and this, right? So if you didn't break anything, now I need to write the Fibonacci program, right? Let's try it. Let's see what we break. And I can't spell Fibonacci. And let's go look up Fibonacci sequence, just to, because I can't calculate the thing off the top of my head. And what does it say? This should actually, first 100 Fibonacci numbers. So if we start seeing something like this, let's see how smart the thing is. The first one. let's just click on any link. You know what? Let's do this. Alpha Wolfram.com. What are the first 100 numbers in the Fibonacci sequence? You suck. Input. No, that's horrible. I'm sure there's a site somewhere but that's okay, because what we can do is say if they're close to this, that's fine, and let's get moving. All right. So, you add class sequence generator. So this will be very similar to what we had before. Internal static class Fibonacci sequence generator. Let's just copy this for now. Except we're not going to keep these because I don't want to repeat code. That's bad. Mutable, runtime, and numerics. Okay. I need to have the last of my muffin here before we truly try to dig into this. I never set my timer, did I? I thought I did. No, I did not. Where are we? We're at 17, so actually when that says like 13 or 15. Okay. Let's try this. So the first line says, if again actions as line exists 1. Okay, so that's going to be our first scope. Just to make sure I got it right. Again says you execute either way. Okay, so no, that's wrong. You just say actions again. There is no scope there, it just happens. Okay. Now we want to say defer. So I want to come back here and grab one of these because that'll be close. So we say defer if 3 exists, or n1 is less than n2, or equal to, or n of 7 is greater than 99. I really should. These compare right. Okay, those are fine. So if we defer that, 3 less than or equal and greater than, then we say update count on 2 to be the number of 2? No, 1. Okay. And then we update 3 with 1 and 7 with 1. 3 with 1, 7 with 1. But not that. Literally, is there a big integer of 1? Yes, there is. Okay, is that right? 3, 7. That's line 1. I should change the other one. I'll get there. Line 2, what does that do? That again's on a 2. We defer on 3, and then we flip these around. 2 and 7 greater than 99. So then we say 1 on 2. 3 gets separated. Okay, that's 2. What's 3? Defer is just a print. Defer in 5, which is all you need. So now we're going to say print. Print n1 plus n2. Except it doesn't, yeah, it doesn't, it knows what this string is. So I gotta do toString here. For now. This is where I don't quite understand how the program, you know, ooh, duplicate numbers there. That's actually bad. Maybe I should have a check in there to say, if you ever did that, that's just wrong. Let me just put that on my list. Okay. 4, what does 4 do? 4 is a defer of 5, you just print 1. Wait, 5, print 1. Okay, don't know why, but that's what I do. Then we do some increments for line 5. Actions, update the line count for 4 to be 1. 3 would be a -1, which I saw in IntelliSense. Nope. -1. 4, 3, and then 7 gets, gets a 1. Okay. Line 6, we got defer on 4. So grab that. No. Yeah, that's fine. Defer on 4. Update the line count for 3 with 1. 7 is just a simple one, so we can grab this. And we just do 7 with 1. There we go. What does 8 do? 8's kind of complicated. A little bit. Okay, so we're going to grab this one for 8. Um, 8 says you defer if 7 is less than 100. And of 7 less than 100. Should do the right comparison there. So then we do the negative for 1. So update line 1. Take -1 times the count of line 1. And then same thing for 2. Uh, 7 gets 100 lines taken away. Okay. These are all minuses. Okay, just making sure. 7. Big integer 100. Maybe there's like a minus thing here that you can say. Nah, there isn't. We'll just do that. Whatever. 1, 2, 7, and 3 gets 1 taken away. But just 1. So we're doing it, yeah, we don't even have to do that. It's just going to be minus 1. Make sure I got that. 1 gets the number of 1 taken away. 2 gets the number of 2 taken away. 7 gets just 100 taken away. And 3 gets 1 taken away. Okay. And then the last line, which is 9, does what? Defers if does line exist for 3 or does line exist for 6? You increment 1 and you increment 3. Okay, let's review our code here real quick. For line 1, you say again, on line 1, defer is does line exist 3 and 1 greater than and less than equal to 7 greater than. You update count 2 with the number that's in 1. 3 and 7 get updated with 1. Line 2, does line exist for 2? Does line exist for 3 or and 2 or 7 greater than 99? You update and count with line 2. 3 and 7 get updated. Line 3, you defer if you have 5 and 1 plus n2. Okay. Line 4, you just print a 1. If you, okay. Line 5 is you update 1, 3 minus 1, 7, 1. 6, you defer 4, otherwise you do a 3, you increment it by 1. Line 7, you just update 7 to 1. Line 8, you defer if 7 is less than 100. Otherwise, you take the number of line 1s and negative it for line 1. Line 2, number of line 2. Line 7 is just minus 100. And line 3 is minus 1. Line 9 is you 3 or 6. Otherwise, update 1 or 3. Well, that makes sense, I guess. But we won't know unless we say Fibonacci sequence generator. Doesn't quite look right. It looks like it's doing something, and it's really hilarious because as it keeps going, holy crap, does the it just takes longer and longer. So you can see 1, 1, 1, 1, 2 plus 1, 2 plus 3 is 5, 5 plus. I don't know if that's actually like this. Eventually. Yeah, eventually. I hear my fan taking off. I'm kind of curious. It shouldn't be taking up a lot of memory. It may be spinning a lot, but it shouldn't be taking up a lot of memory. So let's stop this. And I'm just going to change this thing here because I don't think it means this. I'm not sure. And then I can actually get rid of these because now it's going to assume string concatenation. So let's run that again. Well, I see 1 plus 1 is 2, 2 plus 1 is 3, 2 plus, I get 2, 3, 5. 5 plus 8 is 8. 5 plus 8 is 13. 8 is 21. 31 is 24. 34, 21 is 55. 34, 55 is 89. 89, 55, 114. So if you read this in a certain way, it's actually doing the right thing. It's flip-flopping back and forth between the numbers. So 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5. Okay, stop. But I want to go back through this. So I think it's actually doing it right. You just have to read it in kind of an odd way. So you get 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. So you have to, as you see my mouse going, I think that's how you have to read them. 8 plus 5 is 13. 13 is 21. 20 is 34. 34 is 55. 4, 8, 9. 4, 4, 2, 3, 3. So I think that's right. But as you saw, as it kept going, oh my God, did that just... So if you see two numbers here together, that means you have to do that. And if you see two numbers here, you got to go to... No, wait. And that, and that, and that, and that, like that. That gives you that. So that gives you that. And then whatever that would be. So I take this as a success because I think this is doing the right thing. It just was a little weird to see how it's doing it. And of course, this doesn't tell you crap all of how it actually is generated. So I mean, it's hard to, I mean, again, I see where the numbers are coming from. This doesn't quite look like what this is supposed to print out. So I'm not entirely sure what this is doing. But I guess 7 is a gap to make sure that you're doing the first 100. And yeah, I mean, if I sat here and thought through it, I bet I could get it, but eventually it would do it. So I'm kind of happy with this. Not entirely happy with this. But you know, it does seem to make sense. I'm going to look at this code later and just make sure that what I've coded here is what this does. And I wish this would have said here, you know, the output will look like this. Because the 99 bottles of beer on the wall, that's actually pretty obvious. This one, not so much. What I was expecting it to do is just do like 1, 1, 2, 3, 5, 8, you know, that, and just put them down the line. This seems to kind of funny. So yeah, it does. I'm kind of curious. I'm just gonna open this up. I want to see. Download jar file, extract the classes, and sample program. No, I don't want to do that. Because a jar file, is it just a zip file? I can't remember. Is a Java jar file a zip file? Yeah, they are. Okay, so that's right. I remembered in the back of my head. Let's do a save as. And then let's go to here. Let's call it zip. Open. Oh, that was unexpected. That was unexpected. Oh, it still kept the, okay. We don't need jar in there. We need that. Yes. So what does your fib thing look like? exactly what I saw there. I don't think there's any difference at all. That looks exactly the same. Let me just make sure. Again, for again for no. Oh, now that's interesting. Notice the difference here. There is a -3 here, but there isn't here. Well, let's just try the difference. Let's just see what happens. So, where was that? On line 8. So they're saying don't do that. Now let's run it. I can't really tell if that made a difference at all. It doesn't look like it. It's still bouncing back and forth. So was that an unnecessary instruction? I don't know. It's still doing the bouncing back and forth thing, which, let's see, is there actually... No, they don't have an example of what that should actually do, so that's very unhelpful. All right. Well, we're going to keep it like this. Because apparently taking 1 away from 3 has crap all difference. I don't know why. Because all it does is saying if you print it. Doesn't feel as triumphant, but I think this is good. I'm going to check this out later, and then I'm actually going to commit this as a branch, because at this point, if this worked, which I'm like 99% sure it did, I'm going to merge my branch back in, and then the big step at this point is to now do the parsing. I think I'm finally at that point. I don't think I have everything else on my to-do list I'm looking over here other than making sure all the lines have unique numbers. But that should be simple to do and write a test for. So I'll do that offline, and then I'll commit this. And then the next episode, I don't know, I might continue on with this. I might jump over to doing, to start out Yastari, because that was the other project I wanted to start working on. Or I might just jump back into a couple of other things that I wanted to do. One of them was really doing a hard look at rocks and seeing is there anywhere else I can squeeze some performance out of. And that will require setting up some kind of test program, and then I can do profiling on it and kind of figure out where the hot spots are in it, and also doing some benchmarking on it to say, hey, this is what you did before. Excuse me, this is what you did before. This is what you're doing now. And that actually would be a little bit hard-ish, I think, because I'll want to run it with the way I was the way I did implement it and the way I am implementing it. And I don't know if there's a way in Benchmark to say, it's easy if you have the lines of code there, but what happens if I have 2 versions of the same assembly and I want to see what the differences are? I don't think it can do that. So I might have to play around with that. But I might jump and just do that as a quick break for the next 2 episode or 2, and then start getting into Yastari. But I do have to finish this, because even though I think this will get published eventually in January, by that point I already am doing a talk at CodeMash on this, and so I need to have this functional by then as an actual parser. And it's November, so I have a month and a half left to do it, and there's all sorts of other things I need to do. And I thought, and this is, I thought, going to be the easier part of the two. It's a good foundational step. Now the harder part is to actually get this to compile. So one step at a time. But I think we're in a good state here, so I'm going to stop right now. Thanks for watching. Leave any comments or questions below. See you in the next episode.